The Great Lakes of North America, the largest concentration of fresh water in the world. And the largest of these lakes, Lake Superior, emptying its overflow at only one spot. This spot has historically drawn people from around the world. The original people, Algonquin-speaking tribes of the Upper Great Lakes, call this spot Bawateng, the rushing waters. This spillway from Gitchigumi, or the Great Lake, was carved out by massive glaciers over 10,000 years ago. Over a mile long and some 3,000 feet wide, these rushing rapids were home to an abundance of tasty white fish, easily scooped up with nets from canoes. This spot became a natural trading point for French explorers in the early 1600s, followed by French Jesuit missionaries and fur trappers. The falls came to be known as Les Sous de Sainte Marie, or the Falls of St. Mary. Father Jacques Marquette christened the falls and surrounding area in 1668 when he established a Catholic mission and settlement on the southern shore. Sault Ste. Marie became the first non-Indian settlement in the Upper Great Lakes. It was the site chosen by Sieur du Saint-Lusson to claim North America west of Montreal for King Louis XIV of France in 1671. The French controlled the Great Lakes fur trade through the mid-1700s. Then activity by the British with a fort at Hudson's Bay prompted the French to build their own fort under the direction of Chevalier de Repentigny in 1751 at the Soo. The fort, built on the southern shore below the rapids, was abandoned during the French and Indian Wars that followed. At the end of that war, the French surrendered to the British, and the English set up the fur trade at the Soo by establishing the Northwest Fur Company. They were first to make use of water power at the Soo for sawmills. They also dug a canal and built the first set of locks for canoes on the northern shore of the rapids. The locks were 30 feet long and 8 feet 9 inches wide, each with a lift of 9 feet. One of these locks has been partially restored and may be seen today in front of the St. Mary's Paper Company offices in Sault Ste. Marie, Ontario. Even though the British were defeated in the War of Independence, they still retained western outposts to continue fur trading. It wasn't until the War of 1812 that control of the Upper Great Lakes finally resulted in a joint U.S.-Canadian ownership. An agreement with England established a boundary down the middle of the Falls of St. Mary. Even though the national boundary separated the shorelines, Sault Ste. Marie continued to be the name for all the geographic region around the falls. In 1822, Colonel Hugh Brady was sent to build a U.S. Army fort at Sault Ste. Marie. With the troops' arrival, the permanent population of the Sioux in Michigan Territory consisted of 152 non-native people and a seasonal settlement of several hundred, mostly native and Ojibwa or Chippewa. In the 1830s and 40s, the rapids still provided the chief source of income for the area. People were employed to portage or haul ships around the rapids by pulling them over what is now Portage Street on a grease log pathway. This process took from 6 weeks to 3 months, depending upon the size of the ships. Most of the ships, however, chose the easier method of transferring their cargoes of lumber, copper, and iron ore to wagons or rail cars that took them to waiting ships on the other side of the falls. In 1836, a treaty between the Ottawa and Chippewa and the U.S. government cleared the way for Michigan to become a state in 1837. As more copper and iron ore were discovered and mined in the western UP, the demand for these products grew. To ship these resources out, a lock system would have to be built at the Soo. As an incentive for construction, the U.S. Congress granted Michigan a right-of-way and 750,000 acres of land awarded to the successful contractor. Charles T. Harvey was sent by the Fairbanks Scale Company to survey mineral resources in the Upper Lakes, and he urged his employers to apply. The contract was signed and Harvey was put in charge of the project. From 1853 to 1855, a construction of enormous proportions for its time was undertaken to build a set of 2 locks. A labor force of up to 1,600 men fought cholera and harsh weather to meet construction deadlines. On June 18, 1855, a canal more than a mile long with 2 locks in tandem was completed. Each lock was 350 feet long, 70 feet wide, and 13 feet deep. The gates had holes that opened which let water in and out. Then the gates were swung open for ship passage. All of this was operated by hand. The final cost of construction was just less than $1 million. and a toll was imposed of 4 cents a ton to recover the cost of construction and operation. Getting to the locks and the iron mines beyond required sailing first up the St. Mary's River. The St. Mary's is comprised of a number of lakes connected by narrower streams, many of which had rapids. Both lakes and streams are also separated by numerous islands. This allowed for several possible routes through which smaller vessels could go. But as larger lake freighters came carrying more cargo, dredging a channel in the river became necessary. In 1857, the first dredging work was contracted through the U.S. Army Corps of Engineers. At first, the sailing ships had to take a route north around Sugar Island through Lake George, but traveling through Lake Nicolet and the Middle Nebish Channel proved a better direction, so future dredging was concentrated there. By 1869, 1/3 of all the iron ore and 2/3 of all the copper produced in the United States came from mines on the shores of Lake Superior. These shipments had a direct bearing on the success of the North in the Civil War. Because the size and number of ships increased, the state lock became inadequate, and a new lock was proposed. But the state of Michigan could not afford the construction, so the federal government undertook the financing. Major Orlando Poe was the first Army Corps of Engineer officer to work on the locks. He was 38 when assigned to begin work on the second canal. The contract was awarded in 1870, and he remained in charge of improvements until 1872. Poe then joined the staff of General William Sherman, whom he had served with in the Civil War, and General Godfrey Weitzel was appointed to take over construction. This new lock south of the state lock would be 515 feet long and 80 feet wide, and it would have a new feature providing for taking in and discharging water under the floor. 8-foot square wood-lined culverts passed under the gates. Water came in and out of the chamber through 58 portholes in the wooden floor. Hydraulic power was used to operate the culvert valves and wooden lock gates. This enabled the new lock to be open around the clock, whereas the state lock could only operate during daylight. This new lock was 6.5 feet deeper and 10 feet wider than the state lock. A curved southern pier was also added, originally thought necessary to deflect ice, but in reality proved to be an obstruction and was eventually replaced with a straight lock design. In 1881, the lock was completed and called the Weitzel in honor of General Godfrey Weitzel. Then title to both the locks passed to the U.S. government, and they were placed under the jurisdiction of the U.S. Army Corps of Engineers. The Corps has operated the locks toll-free since that time. The troops at Fort Brady were then given the job of protecting the locks. The fort on the river was moved to the hill just south of the locks in 1898. The fort closed in 1944, and the facility became what is now Lake Superior State University. With the activation of the Weitzel Lock, plans were already underway to replace the aging state lock. The cargo ships of the time were mostly double-masted brigs. Many added steam-powered paddle wheels to increase their speed, but soon the screw propeller would be the main means of propulsion. With more and bigger ships on the lakes, the next lock would have to be even bigger. 800 feet long, 100 feet wide, and 16 feet deep. It was designed to lock 4 of the largest freighters through at a single time. General Orlando Poe returned to oversee construction, succeeding General Weitzel in 1883. This new lock would be named after him. The Poe Lock was built on the site of the original state lock. It would have 5 sets of gates weighing a total of 2.5 million pounds, constructed out of steel. The Poe Lock filled and emptied the same way the Weitzel did, through culverts under the gates, except that 214 portholes were placed in the lock floor to allow for quicker entry and release of water. A pumping plant was also located in the basement of the new powerhouse and office building. This building currently houses the lock administrative offices. The valves for filling and emptying the locks, plus the gates and machines to swing them, were all driven by hydraulic pressure furnished by steam-operated engines. During the mid-1880s, a new energy source burst onto the scene called electricity, and in 1884, electric lights replaced kerosene lights at the locks. Operation of the locks was then run in 2 12-hour shifts with 16 people employed on each shift. In 1885, some 60 acres were added to the grounds, and a fountain and basin were constructed to make the area between the street and the machine house more attractive. Adding to the industrial boom of the era, 3 railroad lines joined at both Saults, so a bridge was needed to cross the rapids and Locks Canal. In 1887, the bridge was completed with a special turret-style track that swung to the side when ships needed to go through the canal. From 1888 to 1892, what became the River and Soo Electric Company was experimenting with hydroelectric generation from a powerhouse in the rapids. They began to supply electric service to Sault Ste. Marie and the Locks in 1892. Meanwhile, the Canadians were busy on their side of the river, completing a lock of their own in 1895. Then, after nearly 9 years of construction, the Poe Lock was opened for navigation in August of 1896. Part of that construction also included some of the current buildings now standing next to the locks. With the Weitzel, Poe, and Canadian locks all in operation and a high demand for iron ore, the shipping industry rapidly grew. Towns were growing as well all around the Great Lakes as people became the main cargo for some of the ship lines. The 1890s were a time of great industrial expansion on both sides of the river, but the greatest growth occurred in Sault Ontario from an entrepreneur and industrialist from Maine, Francis H. Clerg. Under his direction, a power canal and hydroelectric generating company was constructed. Today, that has evolved into the Great Lakes Power Company of Sault Ste. Marie, Ontario. Clerg also founded the St. Mary's Paper Company, the Algoma Central Railway, Algoma Steel, and Algoma Marine, and what is currently the River and Soo Electric Company Power Canal and Hydroelectric Facility in Soo, Michigan. The construction of that powerhouse became an engineering wonder of the world when it was completed in 1902 and is still the longest horizontal shaft hydroelectric plant in the world. 1902 was also the year that a joint agreement between the U.S. and Canada formed the basis for Rivers and Harbors Act, and that gave control of all lands and buildings in the rapids to each respective government. This meant that the River and Soo hydroelectric plant in the rapids would be turned over to the U.S. Army Corps of Engineers. However, River and Soo was allowed to buy back the excess power not needed to run the locks to continue servicing Sault Ste. Marie, Michigan. The river was getting plenty of ship traffic at the time, and further dredging operations were undertaken at Lake Nicolet and in the Nebish Channel. The river bottom had to be deepened and widened. A channel was blasted out of the limestone on the west side of Nebish Island. A dam was set at both ends and water was pumped out. After that, the rock was actually quarried instead of dredged. That channel is now the main downbound channel for shipping today. 1905 saw international attention focused on the locks as the 50-year celebration got underway. 40,000 spectators came to see a naval parade of ships and a military parade down Ashman Street. Vice President Fairbanks appeared on the Coast Guard revenue cutter Tuscarora, and Charles T. Harvey was the chief marshal of the military parade. Theodore Roosevelt was also among the dignitaries. Commemorations were sent from various parts of the world. These included an obelisk at Brady Park and a Japanese torii and kiosk near the public entrance to the locks. The legislators who attended the anniversary of 1905 got a first-hand look at the strategic importance of the locks and also saw that the facility was still too small to handle the increased shiploads of lumber, iron ore, coal, and grain that had begun to flow through the river system. So once again it was time for additional lockage facilities at the Soo. Responsibility for developing the plans fell on the new commander, Lieutenant Colonel Charles Davis. Colonel Davis believed that instead of expanding the existing locks, only one ship should go through at a time to prevent accidents, so another new lock would be needed to handle the volume. The River and Harbor Act of 1907 adopted the project and construction commenced. In 1906, Mr. Louis Sabin became General Superintendent of the canal. The Lake Carriers Association was still concerned because of delays among the wider ships. Even with the Canadian Canal in operation, they hoped for yet another canal to be built. Sabin recommended construction of a second long lock, 80 feet wide and 24 feet deep, and that was authorized in 1912. The new lock excavations were made with 70-ton steam shovels, and for the first time, the new lock gates would be opened and closed by steel cables, operated by electric winding machines. The Davis lock was operational in 1914, and the fourth lock, the Sabin, was completed in 1919. At a length of 1,350 feet each, these new locks were the longest in the world. Controlling the flow of lake waters during this time became an international issue. Therefore, an international joint commission was formed to rule on the concerns of joint waterway usage. A system of compensating gates completed in 1921 by Michigan power companies and the Canadian government provided a means of control. Today, these gates, visible from the International Bridge, help maintain lake levels for shipping and provide high water for hydroelectric generation. By the early 1900s, most of the lake freighters were being constructed out of steel. They were powered by steam engines fueled by coal. The ships were 500 to 600 feet long, 60 feet wide, and weighed 10,000 tons. One of these was called the Lewis W. Hill, owned by the Producers Steamship Line. It was renamed when it was sold and today is called the SS Valley Camp in honor of the Valley Camp Coal Company in Pennsylvania. The ship is now open to the public as a museum in Sault Ste. Marie, Michigan. With 4 locks in operation in the 1920s, the lock force at the Soo grew to 116. Together with personnel at St. Clair Flats and the U.S. Corps of Engineers office in Detroit, this was becoming known as the Detroit District. During the peak years of the early 1900s, freight tonnage through the Soo approached 100 million tons, and at this time the Corps concentrated on improving navigation at the Nebish Channels and Round Island, plus building additional pier space above the locks. In 1929, 92.6 million tons was locked through. But in October of that year, the stock market crashed, introducing the worst depression the country had ever known. Lake freight at the locks declined to only 20.4 million tons. President Herbert Hoover signed a new Rivers and Harbors Act to put people back to work, improving waterways, harbors, and flood control, and money was available once again to further deepen the downbound sections of the St. Mary's River. In 1939, World War II began in Europe, and the next year tonnage at the locks leaped to 89.8 million. In 1941, all records were broken with 110 million tons. The shipping season ended that year on December 14th, 1 week after the Japanese attacked Pearl Harbor. With the increased likelihood of aerial bombardment, there was concern that one large caliber bomb could knock out the whole lock system. So the Soo area soon became the most heavily guarded inland section of North America. There were 10,000 troops stationed here, anti-aircraft emplacements and machine guns, searchlights, and up to 50 barrage balloons were placed strategically throughout the city to prevent enemy aircraft from dive bombing the locks. During the war, 85% of the iron ore used in the manufacture of ships, tanks, and guns went through the Soo locks. With the unprecedented demand for iron ore, Congress authorized another lock, this one to replace the Weitzel. Because of the urgent war needs, the contract stipulated that construction be completed in just over a year. So even though there were sub-zero temperatures during the winter of 42 and 43, construction never stopped. 200,000 cubic yards of concrete had to be heated and mixed and sheltered after placement and protected during curing. That lock was named the MacArthur after General Douglas MacArthur and was officially opened on schedule July 11, 1943. It had the same dimensions as the Poe Lock beside it, 800 feet long and 80 feet wide, and both locks were connected to the same canal. After World War II, President Franklin Roosevelt signed the Rivers and Harbors Act of 1945, and one of the provisions of that law provided for the construction of a new, more efficient hydroelectric power plant in the rapids. Today, only a portion of the old plant still continues in operation. One vertical turbine provides electricity, combining its output with the new plant that went online in 1951. The first priority of the plants is to power the operating machinery at the locks, but through the historical agreement with Edison Sioux Electric Company, surplus power is sold and distributed to the communities throughout the eastern Upper Peninsula. After World War II, a new size of lake freighter was being built to carry nearly twice the cargo of the former vessels. They were close to 700 feet long and 70 feet wide. Now the thought was to replace the Poe Lock with a much larger lock. But first, the St. Lawrence Seaway Act was signed by President Dwight D. Eisenhower to open up the Great Lakes to the Atlantic Ocean. That would also require further deepening of the channels for the larger ocean-going vessels. The project involved 63 miles of the St. Mary's River. By the mid-1950s, 51% of the freight went through the MacArthur Lock, and special handling became necessary with some of the ships that exceeded 660 feet. Work was pushed to begin the 1,000-foot Poe Lock in 1961. Under the direction of Cliff Awney, area engineer at the Soo, construction was ready to proceed. However, discussion with ship owners revealed that they were planning to build ships well over 1,000 feet in length. So a new, longer lock design was approved in 1962, increasing the lock length to 1,200 feet with a 110-foot width. Transportation by car was a concern as well, and in November of 1962, the International Bridge was opened as a joint venture between the United States and Canada. Specifically designed structures were counterbalanced over the lock so that construction could continue and ship passage would not be interrupted. In 1964, the redesigned Poe Lock project was awarded to a Canadian firm, McNamara Construction, out of Toronto. They had considerable experience on the St. Lawrence Seaway and were the first foreign firm ever to be awarded an American lock contract. However, labor and supplies came from the United States. It was a unique project in that it was the first lock ever to be built between two existing locks. The construction and ship passage during this period began to draw record numbers of tourists, so a visitors information center was constructed and viewing stands were expanded. In 1967, the largest freighter on the lakes was the ill-fated Edmund Fitzgerald. At 730 feet long and 75 feet wide, it could carry more than 30,000 tons of taconite ore. But by 1972, it was outdistanced by the first 1,000-footer, the Stuart J. Court. At 105 feet wide, the Court was capable of carrying 55,000 tons. The new 1,000-foot vessels are also capable of maneuvering much better than the smaller bulk freighters. Bow and stern thrusters permit the new ships to turn on a central axis, and advanced radar makes steering more precise. By 1972, the Davis and Sabin locks were ending their useful economic lives, since they could only handle smaller vessels. Today, the Davis and Sabin are considered the ideal locations for a new super lock that may carry even larger classes of lake-going freighters. Since Captain Douglas arrived at Detroit in the spring of 1820, Army engineers have played an important part in the development of what was once America's frontier Northwest. The Detroit District's greatest achievements have been the construction and maintenance of channels connecting the upper Great Lakes, becoming a highway of commerce vital to the growth and economy of the nation. They built harbors, helped control the rivers, acted in time of war and emergency, and built one of the busiest locking systems in the world, the St. Mary's Falls Canal.